Okay, so these are your 8.1 notes specifically focused on direct variation. So there are multiple kinds of variation. This video is going to specifically focus on direct variation. So what is direct variation? Well, direct variation is a special type of linear function. Usually a linear function looks like y equals mx plus b. But for direct variation, we would say y equals kx. And k here represents the constant of variation. Now, graphically, that looks like the slope. Also, you'll notice there's no plus b. That's because the y-intercept is always 0 in a direct variation. So, let's take a look at an example. You might have something that says y varies directly as x the point, or I didn't want to put a period there, I don't know why I did. There we go. And y equals 14 when x equals 3.5. Write and graph the variation. Okay, so there are a couple of important things when you're dealing with variation problems. The problem itself will tell you what kind of variation. It says y varies directly, and we are dealing with direct variation. So that tells me that we're dealing with our formula y equals kx. Now the trick here is it gives me a y and it gives me an x, but we need to find k. So we're going to plug in what we know. We know y equals 14 when x is 3.5. So I plugged in 14 for my y, 3.5 for my x, and I'm going to solve for k. So what I'm going to do to get k by itself is I'm going to divide by 3.5 to cancel over here. But if I cancel on the right, I have to divide by the left. So if I divide the right, I have to divide the left. So we would get that, if you type that into your calculator, 4 equals k. So our variation, to write our variation, let's grab a different color. To write our variation, we would say y equals 4x. That was an awful circle. Close enough. But then it wants us to graph it, which is fine. Could be better. The more I practice with this, the better I'll get. Okay, so we know the y-intercept is always 0. So I'm going to start at 0. And 4x means I'm rising 4, 1, 2, 3, 4, and running 1. So I'm going to go up 4 over 1, and I will draw that line. I don't know why I didn't pull the ruler out to begin with. Here we go. Whoa. Still learning, still working with the technology. Oh, for Pete's sake. Getting closer. All right, there we go. Good enough. So y equals 4x, so we would go like that. And there's our graph. Let's do another problem real quick. Let's do more of a real world situation. Here we go. Example. The circumference of a circle C varies directly with the radius. C equals 7 pi feet when r equals 3.5 feet. Find the radius when c equals 4.5 pi feet. So there's one of the beautiful things about math is there's lots of ways to solve this, but because it says because it says varies directly in our problem, let's start with our direct variation. So it says the circumference varies with the radius. So C equals KR because it's the circumference varying with the radius. So we know it's C equals KR. Well, we need to find K. So plug in what we know. We know when our circumference is 7 pi feet, our radius is 3.5 feet. That is a pair. We know both sides, so I can plug that in. 7 pi equals K times 3.5. And I can solve for K. I can divide both sides by 3.5. It cancels over here, and we would get 2 pi equals K. So notice I only divided the 7 by the 3.5, and I just left the pi alone because I didn't want to work with all those crazy decimals. So now that I know my K, I could write my direct variation. I could say that means C equals 2 pi r. And now I can find the radius when C equals 4.5 pi. So I can plug that in. 4.5 pi equals 2 pi times r, 2 pi r. Remember, when they're all smushed together, that means multiplication. So now I can divide off my 2 pi And in this case, my pi's are going to cancel, so I just need to know that 4.5 divided by 2 is 2.25 equals r. Now that's not the only way to solve it, but that is certainly one method. If you have another way to solve it that ends up with the same place, awesome.